All right, welcome back to Lag Demon Programming. In this video series, we're going to learn about Rust language programming. Rust is an interesting language. It's got a lot of really cool features. It's a low-level, system-level programming language. We can do a lot with it. In this series, we're going to start off doing some Windows programming in Rust. We're going to take our same exact code. We're going to run it in Linux. We'll have to compile it for Linux. We'll run it there. And we're also going to run it and work with it on the Raspberry Pi. And we're probably going to set up some communications between the three and just do some really interesting stuff with Rust. It's not going to be a traditional Rust tutorial where we just go through little bits and pieces. My style, as you know from my other videos, is to do projects. So this is going to be a project-based Rust tutorial, but we're going to step through the Rust programming language a bit at a time, starting with a very small project, bits and pieces, and put some things together. And as we go through, we'll talk about the Rust syntax, the Rust rules, the borrow checker, everybody's favorite, the borrow checker. It's not as difficult as it may seem, but it's a little bit odd, and it takes a little getting used to. And we will work through all of that. So thanks for joining me, and let's get right into it. So here we are on the Rust install page. It's pretty straightforward. You can download the appropriate one. You'll notice that here it says looks like you're running on Windows. If I were in Linux, it would detect that and it would show me the downloads for it. Or same with Mac OS. So I'm not going to go through this. I already have it installed, but basically you just click on this link and download the file and run it, and it'll set you all up. And then there's some things you might have to do with your path. Read through these instructions down here so that you can set your path appropriately so that you can access the Rust compiler and cargo and all that. And we'll go through how to use those tools and when we start off our project. The other thing that I'm going to be doing is in this first project is setting up GitHub, and I'll go through a little bit of that. I'm going to set up some workflows and stuff, and I encourage you to join me on GitHub and write some code, and I will review it. I'll go through that whole process with you, everything that you need to know to be able to contribute code, or just post some code up on GitHub for me to review and give you some comments on. So let's move on to starting off a project here. Okay, so here we are in PowerShell on Windows. If you're in Linux, you can do these things from Bash. The commands are the same. The first thing we're going to want to do is learn a little bit about a program called Cargo. So Cargo is a combination package manager, build manager, release manager. Everything you want to do in Rust, virtually everything you want to do is done through Cargo. And so you can even use it to create projects. So we're going to start. There's a couple different ways that you can create projects, and we'll go through those. Initially, I'm just going to create a binary project, which means it's going to produce an executable. And then I'll go through the file structure and explain a little bit about that. And throughout the course, we'll learn more and more about these things. But Rust has a very specific, at least Cargo, the Cargo Build Manager, has a very specific way in which folders are set up and file naming conventions and so forth. And we'll get into all that and I'll explain it. So the first thing I'm going to do is type Cargo. Oops, helps if I'm actually active in the window. Cargo, new. And I'm going to call this project I should have thought of the name of a project before I started this video, but I didn't. Actually, so what are we going to do? Well, me, I like games. I like game programming. So we're going to create a game, and we're going to ultimately make it a multi-user dungeon. So we'll call this mud. I know what we'll call it. We'll call it Rusty Mud. So cargo, new, rusty mud will create this project. And there it is, created binary application rusty mud package. And if we get a directory here, you see we have a folder named rusty mud. We'll cd into that. And I do have Git integrated in with with my PowerShell. If you don't have that, it's pretty simple to set up. At some point in time, I might show the website. There's a number of these. They're just they're fancy prompts for Git, and they display you some nice information about it. Before we get into pushing this, couple of things. When this created it, when Cargo created it, automatically created a Git repository for me for this project. We're going to be doing some other projects within here and moving this around eventually, and I'll show you how all that works. So I'm not going to be creating the repository just yet. We'll work with Mud, we'll work with Rust, getting kind of the project going and learning a few things about it first. So the next thing I want to do is open this in Visual Studio Code, and hopefully you have Visual Studio Code. The easiest way to open Visual Studio Code in a particular folder is just type code dot. If you're in that folder, you want to open it in, and it will open up that folder. And so here we have this thing called Cargo Toml. I'm going to explain that in a moment. This is our source directory, and you'll see in here there's a file called main.rs. That's the entry point for a binary program. We can also create libraries, and I'll get into that. Libraries have a different file name. They're lib.rs when they're in here, but they can be set up differently, or you can have whole library projects. We have a cargo.toml file. You'll see here that it creates, this sets up some metadata for the package. It's the name of the package, the version, and the edition. In this case, it's 2021 edition of Rust that this works with. So having all that, there's things we can do with the toml file, the cargo toml. We can put dependencies in here to other packages. I'll be showing you crates.io and where we get packages from. You just put the name and optional version number in here, and it'll pull the package for you. You can get those names and version numbers right off of crates.io. There will be a link to crates.io in the description. But I'll also go through crates.io and show you some things. We'll look up some of the packages we end up using in this. But for the moment, we're just going to get in here and start right off by doing some things. I'm going to open up a terminal here as part of my... now I've got this set up with Git Bash in Windows, so this is the bash command. And we can type something here like cargo run. Cargo, well, we can type cargo build. Let's do that first. And it finished. It's a non-snake case. One warning. Interesting. Convert the identifier to snake case. Rusty mud. Oh, it doesn't like the name of my program because that's also the name of my my thing. So you know what? Let's go ahead and fix that, and let's fix that warning and make it all happy. It doesn't matter the directory name it's in. We'll just call this rusty_mud, and let's try a build again. Cargo build, and we can type cargo clean. Now cargo clean will also remove any dependencies that you had, and it'll have to rebuild them all. So keep that in mind if you've got a lot of dependencies. It might take a while to build, but I just wanted to do clean because I wanted to actually build and see if we got rid of that warning, and we did. Okay, so snake case, Rust has a tendency to prefer this, the Rust community over upper lower case kind of thing. We call this snake case. So let's go to main.rs and I'll explain a little bit about this. Let's see what this warning is all about. Oh, I don't know. What's it want me to fix? It say here, change visibility to pub crate. And now we'll just leave that. So This is our function main, and this is how you define a function. You can also put a return type after it here with an arrow and the return type. Typically main has a return type of this, which is unit, which means returns nothing. It's sort of like the C++ void concept, but a little different than void. This is actually print line. It's actually a macro, and this will print out hello world. We'll get into macros eventually in the course, but for right now we'll use a number of macros, and they always end with this. You can always tell a macro call because it ends with this exclamation point or bang. So we can next type cargo run and see our program run, and there it is. It printed out hello world, the infamous hello world program in Rust. You get this automatically when you create a binary crate, which is what we have here. And by the way, we'll go over these terminology a little bit. For now, just think of a crate as like a complete little program. It can also be a library crate. But for our purposes, a binary crate is the entry point to a program. And this program can use other crates, libraries. And you can have in a project multiple binary crates, and we'll eventually get into how that's done. But for now, let's just talk a little bit about what this program is doing. So let's get rid of the hello world part here. And the first thing that I want to talk about in this is a little bit about the borrowing and ownership, because it's important to understand it. When we create a value in Rust, we use the let keyword, and we'll just use let a equal quote this. No, let's do this string from. This is a string. Okay. So what's this doing? I'm creating a value here labeled A, and it's immutable. It cannot be changed. I'm using the string from for a reason, because this part here is what we call a string fragment. We'll get into fragments very soon here as to what they exactly mean and how they work, but this has to be converted to an actual string. When it's converted to a string object, it's actually allocated on the heap. It's immutable because by default, anything you create like this is immutable. You have to use a keyword, MUT, to make it a mutable object. If we then come down here and say print line, and this is some formatting stuff very similar to C# perhaps, and then if we say let B equal A, and we run this program, it printed out this is a string. And then if we come down here and go print line bang, and we run this, it printed it out twice. No problem. Now what I'm going to do is change this to mutable. And we're going to try to execute it here. And it worked just fine. Now what we're going to do is create a function. We'll just call it test. And it's going to take a string. Oops, it's going to take a, we'll just call it A. It'll be a string. And we'll do print ln bang. This is a format string. You can put anything you want into here. We'll do this from test A. And now instead of calling print line here, I'm going to call test A. And I'm going to call test B. Now we get this interesting error value used after move, right here. Move occurs because A has type screen which does not implement copy trait. So what's happened is, let's take this mutable out. What has happened here is this A was moved into use of moved value A. So this is where it was moved, and then we're trying to use it again. Okay, so what's happening is this function up here has taken ownership of this. It's been moved into it. And that means it can destroy it. And so because it's allocated on the heap, this may not be valid when we get here. And this is a condition that happens from time to time in C++ and C, where you've deleted something because you thought you owned it at some point in time in the code, but when that function returns and other code runs, it's trying to still use that pointer. And this is why we created smart pointers and these other things in C++, is to help avoid that particular error. Rust won't let you do it. Rust uses the borrow checker, it's called, to ensure that these things work the way they're supposed to. Now, if we want to just lend this, in other words, have this thing not take ownership of it, let's make this ampersand string. And what we have to do here is dot to dot as str dot as str. Oh, let's do it up here. Dot as dot as str, and then we'll just put B in here. Run it, and now it prints it out both times. So what have we done? Okay, this lowercase string is called a string fragment, and this ampersand says that we just want a reference to it, and we don't want a mutable reference, we want an immutable reference, which means that we're not allowed to destroy this when we're done. In other words, this isn't going to, when this falls out of scope, it isn't going to get destroyed. And I'll go over a little bit more about scoping in just a moment and show you how that works. So this function, when this was a string before, it got it, it took ownership of it. When this function exited, the system said that string is no longer needed, and it gets automatically deleted. With a string fragment and a reference to it, there's nothing to delete. It's not a deletable thing. It's not owned by us. We're simply borrowing it, which means that it survives this. We can do this here and change this all the way up here to as str. Can't type. Then we can get rid of this. We can get rid of this. And we can run it again. Borrow later used here. So we've got a problem here. Oh, this is as an ampersand string here. And then we cannot temporary value dropped while borrowed, borrow later used here. So let's get rid of this for the moment, and we'll go over this a little more, perhaps a little more clearly. So actually we didn't want this or this. We're just going to create a string fragment here. So this is a string fragment, and it just kind of exists right here in our stack. So actually let's turn this back into a string. For the moment. Now what I'm going to do is I'm going to create a scope. if we create this inside this scope, and then we come down here and say let B equal A, we'll see another kind of error, and not found in this scope. So A right now only exists inside of this scope. It does not exist out here in this outer scope, so it's been deleted when we got here. If we move this up to above this scope, that runs, but we've got a scope in between here, so let's do something with it. In this scope, let's do something like let B equal A in here, and let C also equal A, and run that. Value used here after move. So what's happened here is this value here was used within this scope, assigning it to B. It moved it to B. Okay. Now it is owned by this scope here. And when this scope exits, B gets deleted, which deletes A. So we can no longer use A here at this point. Okay. But if we made this a string fragment, it ran. Of course, we're not printing anything out, so let's print something out. Comma C. And run that. And you see now it printed it out. Because this is only borrowing the value, we could do something in here like and it prints it out twice, because this is just borrowing it as a string fragment or a reference to a piece of a string. And we'll get into that. You can make string fragments of portions of existing strings, starting from one index going to another index and so forth. But for now, we're just going to deal with this. So that's just a little kind of intro to the borrowing. We're going to deal with this borrow checker a lot throughout our programming, and I'll explain things more and more as we go through it. This is just kind of an overview. The next thing that I want to talk about in this little intro here is our command arguments. Okay, so command line arguments. When you type in a command into Windows, you run some program, my program, and you pass some arguments. The operating system packages up the arguments and makes them available to the program that's being executed. The way those arguments work out is the 0th argument, the first one in the list, is going to be the path to my program. And then there will be whatever the value of arg1 is, and then this minus help, minus whatever, and some file will be in that order. So this will be 0. Oops. This one will be 1. This one will be 2. Oops. This one will be 3. This one will be 4, and so on. Okay? So how do we capture those? Well, in C and C++ and even C#, you put the arguments in here in some form or fashion. In C and C++, it's argv and argc. It's very similar in C#. In Rust, you don't put anything in there. It's just the main function, and we use what's called the environment. To get a hold of the environment, we use a use statement like this. All this is saying is there's a standard library that comes with everything. It's already loaded. Everything's ready to go. We have to bring it into scope, what we want from it. Okay, now we could put a star in here and bring all of the standard library into scope. We don't really want to do that. In this case, we're going to bring env, which stands for environment, into scope. And what we're going to do here is create some arguments. We're going to say let args equal env : args dot collect. So what does this do? Arguments is an iterator over each one of these arguments, and collect just turns it into a collection. We'll be working with various kinds of collections over time. This, by the way, is a vector of string, is what it needs to be. So args here is a vector of string collected from this. And if we just real quick come down here and run this, it successfully ran without any errors. Now let's print out each of the arguments that we pass. So to do that, we have a collection. We're going to go for arg in args. So this is going to create an iteration across those, and each one of these is a string. You see this is a vector of string. It's pulling each one out in turn. Let's print them out. Print line, bang. Let's do this and this, and well, no, we'll just do the one for the moment. We'll do the other one later, and we'll just put arg in here. And let's run this. And all we got was target debug rustymud.exe, which is the executable file. Let's run it with some arguments. So now it printed out that 0th one, then it printed each of the arguments that I passed in. Something in, what did I type? Minus help. Okay. So it printed out each of those strings one after the other. So that's how we're going to get the arguments. There's other ways we can access it. If we know that we need a certain argument, we can, for instance, check the length of this. We can say if args.len is less than 2, please specify an argument. Else we can say args dot interesting. Why am I not seeing anything? For args here. Okay. Sometimes Visual Studio gets a little confused. I think it's partly because I didn't do this, comma, args dot args sub, we'll say 1. So now if we just run it normally, we should get please specify an argument. If we tell it test, it prints out test. So we only printed that one argument. We could also say does not equal to, please, or no, we'll make it less than 2. And we can say else if args.len is greater than 2, else too many arguments. So now if we run it with no arguments, we get, oh, oops, made a mistake. We run it with no arguments, please specify an argument. Too many, test, test. Too many arguments, test, just right, it prints the one out. So there's a little bit about flow control, a little bit about getting the arguments out of our string, which we're going to need in our overall project. All right, now thanks for watching. Really appreciate it. That's just a quick intro to kind of what we're going to be doing, and a little quick intro to some things in Rust. In the oncoming videos, we're going to go step by step through some of these things, especially the borrowing and ownership concepts, scoping, package management, and the whole 9 yards. In the next video, we're going to set up our project in GitHub and go through the process of what we're going to be doing as far as changes. So you can join me on GitHub, you can participate, you can write programs in Rust and post them up to my GitHub site. That'll be done through a process, and I'll show you how that's done. You don't have to worry about a thing. You can't mess anything up. It's all automated. You won't be able to get anything through my automations without my permission. So don't worry about it. Post away, and I'll give you feedback. And who knows, maybe we'll even work out something where I'll put up some homework assignments that you can pick up and go work on, and come back and show them to me. And hey, good stuff that's usable. We'll incorporate it into the project, and we'll talk about it. You can also get feedback from other users. So I'm looking forward to that. In the next video, I'll tell you all about how to join me on GitHub, and to how to participate. So thanks for watching. I hope you liked it. If you really liked it, hit that like button, and I really appreciate the subscribers. We're almost at 1,000. 1,000's a big milestone for me, and so hopefully I'll get some more subscribers here in the near future, and we'll get up over that 1,000 mark, and we'll really be rolling then. And so I really appreciate everybody's participation. If you want to get notified of new videos as they come out, hit that notification button, and I will see you in the next video. Thanks for watching.